Binary to octal. When we're doing octal conversions from binary to octal, group binary positions in groups of 3. Write the octal equivalent. When we're going from octal to binary, we reverse the process. And if we're going from octal to decimal, we multiply by the weighting factors. And if we're going from decimal to octal, we can do the successive division. Now we have our hexadecimal numbering system, which is our base 16. In this system, we have 16 allowable digits, which are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, and F. Each hex digit represents a 4-bit group. As you can see here, we have our hexadecimal numbering system, 0 through F, and each hex digit represents a 4-bit group. As you can see here, it's groups of 4 in the binary. The 2 hex digits are used to represent 8 bits, and 8 bits are called a byte, while 4 bits are called a nibble. In our hexadecimal conversions, binary to hexadecimal conversion, group the binary in groups of 4. Then you write the equivalent hex digit. The hexadecimal to binary conversion, we reverse the process. The hexadecimal conversions, we go from hexadecimal to decimal conversion. We multiply by the weighting factors. The decimal to hexadecimal conversion, we can use a successive division. Binary coded decimal system, or other known as BCD. Each of the 10 decimal digits is represented by its 4-bit binary equivalent. The decimal to BCD conversion, you can convert each decimal digit to its 4-bit binary code. And the BCD to decimal conversion, we reverse the process. Here is a comparison of all the numbering systems, which is a decimal, our binary, our octal, hexadecimal, and our BCD. Numbering systems applications. Because digital systems must work with ones and zeros, learning the different numbering systems is important. Which systems is used is determined by how the data were developed and how they are to be used. Several numbering system applications follow. Application 1. The 4 chemical storage tanks shown are monitored for temperature and pressure. As you can see in this diagram, we have tank A with its pressure and temperature going into this computer monitoring system. Using the table shown below, interpret the following. If the computer reads a binary string of 00101000, what problem exists? So if we were to take these numbers and insert them into our table shown, we would end up with pressures in tanks C and B are too high. Pressure tanks in B and C are too high because these both end up representing O1. Using the same table, if the computer reads a hex value of 55H, what problem exists? Since 55H is equal to 0, 1, 0, 1, 0, 1, 0, 1. This indicates that all the tank temperatures are too high. Now, if the temperature and pressure in tanks B and D are too high, what hex value is read by the computer? This condition would produce a digital output of 11001100, which is equal to CC in hex. Now, if only tanks A, B, and C are monitored, what octal value indicates tank B has both temperature and pressure problems? The binary output would be 001100, which is equal to 14 in octal. Now, typically, digital thermometers use BCD to drive their display. How many BCD bits are required to drive a 3-digit display? We will use 12 bits because 4 for each digit. And what 12 bits represent 147 degrees Fahrenheit? We have 0001, which is equal to 1, 0100, which is equal to 4, and 0111 in binary, that's equal to 7. Now we have the summary of what we just went over. Numerical quantities occur naturally in analog form but must be converted to digital form to be used by computers or digital circuitry. The binary numbering system is used in digital systems because the ones and zeros are easily represented by on or off transistors, which output 0 volts for 0 and 5 volts for 1. In any numbering system can be converted to decimal by multiplying each digit by its weighting factor. The weighting factor for the least significant digit in any number system is always 1. The binary numbers can be converted to octal by forming groups of 3 bits and to hexadecimal by forming groups of 4 bits. And successive division procedure can be used to convert from decimal to binary, octal, or hexadecimal. And the binary coded decimal or BCD system uses groups of 4 bits to drive decimal displays such as those in a calculator.